Um, as he said, my name is Laura Vernon. I'm the Sovereign Lands Planner for the Division of Forestry, Fire, and State Lands. And for those of you who may not know, the division is tasked with managing the bed of the Great Salt Lake for the public trust. So the exposed bed you see is ours, and the water, or what's underneath this, the water is ours. So can I have by show of hands, can you tell me if you were at part one of our presentation last year? This is for two reasons. Okay, great. Not many of you. So the first reason I wanted to know how far we should dive into like the purpose and need of the integrated water resources management model. But the second reason was because I don't want you guys to blow my secret about what's going to happen to the Great Salt Lake. So I'm just going to tell you, I think this is the $1 million question, right? What's going to happen to the Great Salt Lake with changes in climate, with precipitation, with future land uses? What's going to happen? And the big answer is we don't know. But we're developing a tool in the with the Department of Natural Resources that's going to help us better understand and better get to this question about what's going to happen with the Great Salt Lake. This new NASA imagery, I don't know if you have all seen it, shows the south arm of the Great Salt Lake, lake level elevation 4197 in 2011. It was a really wet year. And then we're fast forwarding then to 2016 where it was 4192 at a near historic low. And people are always asking us as managers of the bed of the lake, what's going to happen to it and how low is it going to get? And you know, how much water is going to come down from the mountains? And we haven't been able to provide that great of an answer until now. You'll remember back in the 1980s when people were asking how high is the lake going to get, how many areas are going to be flooded, what will the lake level get to, and now they're asking on the other end of the spectrum, how low is it going to go? So we're excited to develop this integrated water resources management model as a tool that will help us answer some of these questions. Specifically, the model will help us understand how future changes in water supply will impact the Great Salt Lake with regard to lake level and salinity. So within each of the bays, how the lake level will be impacted and the salinity levels in each bay. So this is like changes in the watershed, not just within Forestry, Fire, and State Lands jurisdiction. It's outside of it, up in the Cache Valley. And you can see this picture's not too easily seen, but you can tell we're looking at the Great Salt Lake watershed, which is a big step up for us because our management is, like I said, the bed of the lake. But now, in partnership with other agencies, we're looking at the watershed in general. So how do changes in if population increases in Cache Valley, or if land is converted from ag use to residential homes, how does this impact the levels in the Great Salt Lake? For those of us who are concerned about it, excuse me, we all know that it's a valuable ecosystem unique to anywhere else in the world, but we know that it's also a significant economic driver in the state. And so how do we make sure that this lake is sustainable? So the need for this specific project, there's been a lot of work done on the Great Salt Lake in the past 10 years. It's been a great partnership with all the universities and state and federal agencies learning more about the lake. So we have that piece. And then we have people upstream from us who have a great amount of information and knowledge. We have water users, conservation districts, municipalities, other divisions, but there's no one agency that's integrating all that information until now. So that's what we're doing with this partnership. We're working with 5 other state agencies, Department of Natural Resources and Department of Environmental Quality, to build this tool that integrates all of the different pieces of the puzzle that will give us a more comprehensive explanation about what happens to the lake. So the tool needs to support management decisions. So we're going to show you in a few minutes a case study that's happening at this very moment about when will be the most appropriate time to breach the causeway, the new railroad causeway. And so we've already put the model to use, working to support our management decisions. Should we have the breach begin in December? Should it be next year? So we're putting the tool to work already. We want to help evaluate scenarios. So if a mineral extraction company comes to the division and they want to expand their evaporation ponds, we can develop a range of scenarios that will look at how this will impact the lake levels and how it will impact the salinity. We can grow their ponds from big to small and see how those scenarios would impact the lake. We can also evaluate scenarios if there are diversions upstream from the Great Salt Lake, how on the Bear, for example, the Weber or the Jordan, how those diversions would impact the lake. So we're excited to have the tool in hand ourselves. In the past, when people have come to us with proposed projects, we've kind of been at their mercy where we don't have the tools and the data to run our own analysis, and we've been at the mercy of some of the other applicants coming to the door. So it's nice to have our own tool to be able to consider what the impacts are. And then this is going to be an important communication tool for venues like this. We can explain clearly through the model why we're making the management decisions we are, and we have the best available science and data to get behind. And I think it will be a good tool to help explain why we're doing what we're doing within the division. Developing this model is a big challenge. We got to figure out kind of the sweet spot, right? We got to figure out how to balance all of the details. How many things can we cram in the model to get out the information that we need? For example, how much wetland data and information on the Bear River and the lake itself can we put in there to get information on the consumptive use of Phragmites, for example. So we want to make the tool operational. We don't want to put too much in, but we want to make sure that the information that we put in is relevant. And then we want to provide flexibility for adding on to the model in the future. So like I said, we're really excited about working with the 5 divisions on this now, but many of the divisions are excited to add on to it later. Like if a year or 2 down the road, the Department of Environmental Quality wants to have another question answered about the lake, they can plug into this. We want to make sure that the model is still operational and that it is doing what it's intended to do. So with that, Jeff Denblicker is going to talk more about the challenges and the knobs and the dials that are used to create the analyses for the Integrated Water Resources Management Model.
All right. Thanks, Laura. So I think when we started this project, obviously we had the big question of what's going to happen to the lake. The state agencies wanted to develop a tool that they could use so they could start to understand different scenarios that could happen not only within the lake but also within the watershed. Start just asking a lot of the what if questions. What if population doubles? What if we conserve more water? What if we move water between basins? What are the potential impacts of those actions on the lake itself? And so I think, we all have a different position in our watershed, and oftentimes we're looking up in the mountains and we're looking downstream. I think what we're really trying to do with this model is starting at the lake and looking up into the watershed, looking up the valleys and up into the mountains, and to see what the changes that could happen up in the watershed, how does that influence the lake? And I think one of the key challenges we had here was because this was an amazing opportunity where the different agencies were working closely together to develop this tool. One of my pet peeves as an engineer is typically we develop a model, we answer a few questions, and then the model just kind of sails off into the sunset, never to be used again. In this case, the agencies wanted a model that they could use as kind of a foundation, a place to start from, a place that they can model that they can continue to maintain and develop into the future. And so a lot of the work that we've done has been really focused on that, trying to make sure that this model is not just technical in nature, but it's also addressing a lot of the business and social aspects within the agency, but then also amongst the stakeholders as well. And so when we started the project, we spent quite a bit of time talking to a lot of different stakeholders to try to understand, well, what kinds of scenarios, what kinds of variables are people interested in understanding to see what those impacts might be on the lake. You can see here a pretty long list. The original list was much longer than this, 3 or 4 times as long as this. But really, one of the key things is we wanted to get out of the model was what is the lake level and salinity going to be if we start to play with some of these variables. And the model doesn't address all of these variables, but what we try to do is create a framework that's flexible enough where we can add that functionality in the future when it's needed. So I just want to kind of run through some of the screenshots from the model to kind of show you what kinds of things we're looking at. And we're still in the beta testing phase of the project. But what you see here is just kind of a characterization of the overall model. At its core is the lake model, lake module. We're using the USGS model that was originally developed by the USGS, later updated by the Union Pacific Railroad and USU. And so we're using that and bringing that into this model. We're adding a wetlands module. I'll talk about that here in a minute. And then, of course, upstream of that are the 3 river basins. And so from this home screen, you'll be able to access each of those parts. Starting at the lake, this is kind of the home screen for the lake module. But what we really try to do is capture, and there's a lot here. And what we try to do is, like I said, we're trying to understand what are the kinds of variables that people are interested in and the knobs that they want to try to adjust to see what the effects are. And so with the lake module, there's a lot of different things that people want to do. And I guess another challenge that we have with a model like this is making sure that this is a model that people can reasonably use, say in a meeting, or be able to answer questions pretty quickly. So you want to get the overall model runtime down to below 30 minutes, ideally below 15 minutes. And so our intent is to be able to allow a lot of functionality for the user to say, well, all I'm interested is what's going on with the lake, and they can turn off the river basin. Our first run with the 6-kilometer grid scale, the model is taking close to an hour to run. And so we've decreased that to a 12-kilometer grid scale. And our intent is to be able to decouple the river basin model so you can just run the lake model, which runs in about 10 seconds. So very easy to get answers quickly. But here you can just see some of the key questions that people wanted to look at as well. What happens if we start with the conditions we have today versus what we had back in 1984 when we run the model? Different inflows. Here's an opportunity for you just to say, you know what, I want to just increase or decrease Bear River inflows by a certain percentage versus looking at letting the river basin do the the model do the hydrology for you. The pump station, looking at the causeway characteristics. What I guess the main takeaway here is that what we're going to be able to do, and I think right now the screenshot only shows the north arm and the south arm, is we'll be able to compute how the water surface and the salinity will change in all 4 bays, Farmington Bay, Bear River Bay, the south arm, and the north arm. And this is really what we did is we just basically took the USGS model infrastructure and replicated that within this model. The Wetlands Module is a new addition. The old USGS model took river basin data at the flow gauge and assumed all that water got to the open water of the Great Salt Lake, and then they used the evaporation to calibrate the model. What we're doing is trying to account for the fact that there's a lot of water that's used in those wetlands and account for that. And so just briefly, we identified 6 different, kind of aggregated the wetlands around the Great Salt Lake in 6 different areas. You can go in and we have all the different wetland area use classifications as well as vegetation types. And you can come in here and play with the evapotranspiration rates by adjusting KC values. These are values we got from the literature. And then you can zoom into, say, Farmington Bay wetlands and say you can adjust the acreage. You can adjust the different percentages of the different types of vegetation, types of wetlands, and look at, well, what kind of effect would different management decisions have on consumptive use in those areas. So now zooming out to the river basins, as I mentioned, one of the key things we wanted to do is make sure that that this model is something that people are going to use. And a lot of times, and I'm completely guilty of this as well, is we've really focused on the technical part. And we spent a lot of time really focusing on, well, what do the agencies actually do every day? What kinds of data sets do they generate? How can we incorporate those workflow processes and databases into this so that we're not creating a new burden on them. Because that's really when the models start to get pushed aside. And so what we did is we used the state's Division of Water Resources river subbasins as the core for this model. And here, this is looking at the overall, the 3 river basins that go into the lake. But here you can see, you can start to look at some of the key global variables that you can adjust from a global standpoint. So you can adjust M&I, municipal and industrial use rates. You can adjust climate, how the climate might influence the hydrology. And just very briefly, at its core, we use what's called the Vic Model, developed at University of Washington. Bureau of Reclamation uses it quite a bit. We've used it a lot on regional watershed models like this. But it accounts for everything from the precipitation coming down into the river basin, the evapotranspiration, what's lost to groundwater, and then what runs off. And so for each river subbasin, we do a water balance. And we look at what comes in, what comes out, and what goes out is reported down to the next basin downstream, and continue that through. We also try to make sure that we're using what the Division of Water Resources, their data sets that they already update, and incorporated that into the model. Again, with an attempt to try to make sure that this model is as sustainable as possible. Looking at, you can drill into each of the river subbasins, and again, you can look at different variables and adjust those to see just on a river subbasin level how might, changing water use rates or using, land use distribution, or population even, how might those affect the water balance. Looking at just purely water use, we can adjust the population. We use the state's census data and population projections throughout the entire watershed. But you can start to look at urban outdoor use, what kinds of scenarios might you have there, different residential uses, including conservation, commercial, industrial, institutional use, looking at runoff, adjusting runoff in their urban areas. All these are different variables that feed into the water balance that the user will be able to adjust. And then this is just kind of a framework of the overall watershed where you can click on any one of these things and see the results, and also drill into the different variables and data sets that go into the water balance. So I know that was a very quick overview of the model, but that, the intent here is to have something that users, all of you will be able to make some sense out of. And it's an initial framework that other data sets can be brought in, that other users can add their input. So if someone has their own, for example, river basin model, they can take their input or their output from that model and attach that to this one and see, well, how these management decisions in the watershed affect Great Salt Lake. So there should be a lot of flexibility that can be built into the model there. So just a quick case study, as Laura mentioned, Union Pacific has a causeway across Great Salt Lake. They had 2 culverts that failed. They filled them in, and they went through a long process to get approval to build a bridge across the lake. You can see there's the best picture I could find showing the new bridge, but also a berm that currently separates the north arm and south arm. So the key question that the state needed to answer was, when should we breach the causeway? And they wanted to look at 3 different scenarios. Do we do it now? Do we do it next June after spring runoff? Do we do it a year from now and hope that we get a great winter this year? With the goal of minimizing impacts on lake level and salinity. When we ran the model, the state used their USGS Fortran model, and then we ran the beta test version of this watershed model in parallel. We ran it deterministically and stochastically. Obviously, a big question is well, what kind of winter are we going to have? Because if we knew we're going to have a big winter, it probably isn't going to be as important as if we have a dry winter. But so we use different methods to look at what might happen. So here you just see representation of the stochastic results. And really what we're doing is we're saying from 1987 to 2012, here's the snowpacks that we had each year. And we just run the model looking forward, assuming that we have the winter of each year. And so statistically we can say, well, it looks like we're going to be most likely here, but here's the range that we can see. And so the conclusion from it was just the models correlated very well. We were very pleased with how they matched up. We did find some improvements that we were able to make in both models. But the conclusion was really that, yes, there's going to be some changes in the lakes as it responds to the opening, but the timing of when we do it isn't a big factor. And so Union Pacific can open their breach and meet the requirements of their permit. The brine shrimp industry won't see significant impacts from, depending on the timing, and the mineral extraction industries can get some water in the North Arm so they can continue their operations. So the next steps, as we mentioned, we're currently in beta testing. We're working through and trying to define a rollout strategy here over the next 6 months. We intend to be done with the model in January, and then the state will be taking the model, running it, going through its paces, documenting here are the key variables, and kind of doing a sensitivity analysis on the model, and then rolling that out in second quarter next year. So I just want, Laura mentioned the different agencies, but it was just fantastic to sit around the table and hear the questions, the discussion, all the agencies talking about, here's what we do, the questions that they had, and trying to figure out how we can make sure that this model really meets all of their needs and their day-to-day jobs. I just want to leave it here. This is a great picture of how, as a watershed, we all have a role in the water that's going in, water that's in the watershed that we have. But the one thing I don't like about this is that the water just kind of disappears off the end of the table. And I think with Great Salt Lake, obviously, we're in a terminal basin, and the water that gets to Great Salt Lake does have an impact on our watershed, whether it's through the, affecting even just affecting the snowpack that we have in the mountains here. What we do in the watershed does influence the lake, and then it comes through a feedback loop. So with that.
Okay, thank you, Jeff. Do we have any questions for Jeff or Laura? I'd like to have them on the microphone if possible. This is being filmed.
So the graphs you showed that had different shades of red, is that the confidence that you have for the model, or the error where it could go potentially?
Yeah, so every time we run the model, and when we run the model, it'll run it about 1,000 times. Okay. And it just changes some of the different assumptions that go into it. And so then statistically, we can say, okay, from, we're 95% sure it's going to, it will fall between this band. Okay. But then we can start to look at different limits and say, okay, well, we've got, here's the mean of where everything falls, but then here's the overall width of. So it's just a way to describe what we think could happen in the future.
So is there a way to take out some certain relationships and correlations to get that more confident?
Yeah.
Or is there a way for other people to say, oh, okay, this is what's making it have more error, this relationship?
Yep. I mean, you can go through the sensitivity analysis and really understand what variables are affecting that confidence that we have there. And really what it comes down to is what kind of data do we have? Here we don't know what's going to happen this winter. If we run this model next February, we could probably have a lot better confidence of what's going to happen. Okay. Because now we don't have to look at a 30-year record. Now we can take out the data sets and say, okay, well, here are the winters that were most likely what we had in 2016, 17, and now we can run the model again and have a much tighter band.
Cool, thank you.
More questions? Do we have time for probably another question?
Laura and Jeff, on the model, you have an outcome that helps guide and inform a decision on the causeway. Does the model provide results relative to the other spectrum of benefits and uses of the lake? I know that the state has looks at the lake level and how the health of the lake under different parameters with this ecological, environmental, from extractive industries. So is the model adapted to provide those sorts of decision points and information?
I think, correct me if I'm wrong, Jeff, but we're just focusing on the lake level and salinity, but how breaching the causeway would impact phragmites or waterfowl. We can't say those for sure. We're just looking at those two variables.
So it doesn't give you the answer to everything.
No.
But Tom, I think that lake level question is really the core of most of those management issues. Because if we know what the lake level is, or we can have a better understanding of that, now we can look at, well, how much habitat do we have for shorebirds, or how much how much of the mudflats are now exposed, I know Division of Wildlife Resources is developing a model of brine shrimp and brine flies, and that whole relationship, key to their input to their model is lake level, salinity, and lake temperature. And we're able to kind of characterize, here's the lake level and salinity, and then that helps them with their decisions.
Well, unfortunately, we are out of time in the interest of moving things along in a timely manner. I'd like to thank Jeff and Laura very much for the presentation. I'm sure that they'll be happy to answer more questions individually here. We need to get ready for the next session. And I want to remind everyone